title is Isolation and Identification of Carotenoid Bacteria Strain from Birdhouse Soil Sample in Thang Binh Quang, Quảng Nam Province. So, before I start my presentation, I have a question for you. Have you ever eaten fried chicken rice? It sounds fancy, but in Vietnamese it's named Tôm Gà Xôi Mỡ. Okay, and I have another question for you. Have you ever recognized that the main product of many fast food brands like KFC, Texas, McDonald's, Jollibee is chicken? That is the main product. The main product here is that chicken is everywhere because it's delicious and cheap. That's why chicken account for the highest meat consumption compared to other type of meat. But I have another question too. With that large amount of chicken meat consumed every year, so where did the feather go? Well, it goes straight to the environment. And you know what? It causes soil and air pollution. How? Okay, so the main component of feather is keratin. And keratin contains high concentration of cytosine, which is in amino acid that form distributed bond, and it is very stable in interaction between molecular. So that's why it makes feather is really hard to be degraded in the environment, and it's called pollution. Sometimes it takes months or years to be completely degraded, and it becomes a problem, waste problem. So scientists learn how to turn this waste into high-value products. Is amino acid that they can turn into, it can add amino acid into animal feed or fertilizer. However, hydrothermal and chemical method raise two problems. First, it can destroy some value product like tryptophan, and it also releases CO and NO2 into the environment and cause air pollution. So I bring here a better solution is biological method is carotenoid bacteria. This bacteria able to decrease feather by two steps. First step, it breaks the disulfide bond by release chemical and protease. And protein then denature and specific keratinase too easy to attack into the polypeptide and cut it into amino acid. So talking about the feather waste, the main component of it is beta carotene, and beta carotene can find in many types of bird like squidlet or chicken or duck. And in many previous studies, people only focus on the soil from the chicken farm. However, there was no previous study focused on the soil from birdhouse. This is how the people raise squidlet, edible bird nest. So this is a very potential source to isolate carotenoid bacteria because feather everywhere and it degrading. So I decided to carry out this study with the question in my head that can bacteria isolated from birdhouse soil be used as a potential solution for the chicken feather waste problem. So here is my study objective. First, isolating and identifying carotenoid bacteria from birdhouse soil sample. And then I evaluate the feather degrading ability for further application in solving feather waste problem. So to achieve this objective, I select 12 soil samples in Quảng Nam Province, and then I enrich it into the feather medium broth, and I dilute it 5 times, and I isolate it based on the skimmy agar. So skimmy is a very common protein that is easy to be degraded. And the bacteria that can release protease will digest the protein and it create a hollow zone around it. So I will isolate these bacteria. However, I only need the strongest one. So I move to the select step. The first step in selection, I first select the strong protease producing bacteria based on well-diffusion method on skimmy agar, and I incubate it for 1 day. Then I measure the diameter and I run the multiple random analysis to choose the strong protease producing bacteria. And I move to the second waiting before and after after the screening process, and I using this formula to calculate the percent of chicken feather degradation, and I chose the strongest one. So after I have the strongest 30-layer bacterium, I will identify them by morphology, biochemical test, 16F RNA sequencing, and mannitol. And I also calculate the enzyme activity using the cell-free solution, and based on answer method and using casein as a substrate. And I'm using this formula to calculate the enzyme activity, protease activity. And the most important experiment here, I test the degradation ability on the whole feather. I let it degrade 5% chicken feather, and I also calculate the percent of chicken feather after 7 days. So I won't let you wait for too long. Here we come to the result. So from 12 cell sample, I isolate 40 protease-producing bacteria. And actually, I expect that the longer the history of the bird is, the bird health is, the higher total isolation I have. However, there was no any connection between that two data. Next, from 40 isolate, I found 6 potential isolates that show statistics different with the rest, and I use these 6 to for the secondary screening. So in this experiment, MD1113 showed the highest percent of chicken feather powder degrading after 4 days, and it shows it at the most potential catabinoid bacterium. And in identification part, so about the morphology, it have the white in color, it grows rapid, and the surface is smooth. And I also carry out several biochemical tests, so it's able to ferment mannitol and glucose, and able to ferment lactose. About the 16S RNA sequencing, so when I got the sequencing result on SCBI gene bank, it did match with any 16F RNA results or data on the gene bank. So it only matched with some vector. So I cannot conclude anything here. So I use another method in mannitol, and the result is bacillus cereus. So I tried to last one again for specific bacillus cereus. Then it matched with the bacillus cereus plasmic. So, and I then use this result to check with the morphology and biochemical test. So it completely matched with the bacillus in general. So here conclusion, I conclude that MD1113 is close to bacillus in general. About the enzyme assay, so here the tyrosine standard curve, and here is the result of the protease activity is 0.17 unit per milliliter. And about the whole feather degradation test, so after 7 days, it completely degrades the feather, and it's very potential bacteria for solving the question that I mentioned at the beginning. But come to this step, I wonder that can this enzyme and bacteria can they apply in cleaning the animal bird nest, because we also need to remove the feather out of the bird nest. I just have that question, and I carry out small experiment beside the main idea. So here is the experiment related to animal bird nest. I dip it into crude enzyme for 1 hour, and I try before and after, and I analyze the weight and also sensory analyze it. So here is the result. So after 1 hour, the weight of bird nest lost around 10 to 12%. About sensory analysis, the color seems darker. Above is the before cleaning, and below is the after cleaning. And the shape seems lost the internal shape. And particularly about the feather concentration, is not significant different. Why? Because based on the previous experiment, it did at least 7 days to totally degrade feather. further. However, this experiment only conduct in 1 hour because after 1 hour, the edible burden already turned into the soft term, so I cannot carry out the experiment. And besides that, the reason why the weight loss is 10% because the main component of edible goodness are also protein and amino acids. So after 1 hour, it's also be degraded by microenzyme. So I come to the conclusion. From 12 soil sample, I isolate 40 protein-producing bacteria, and MG1113 is the most potential keratomycin bacterium, and it's close to bacillus. The protein activity is 0.17 unit per milliliter, and it can completely degrade the feather after 7 days, and the crude enzyme cannot completely free the edible goodness after 1 hour. Here's some suggestions. I suggest that the next studies should optimize the culture condition and feather degrading condition for MV1113, and they also should test on the other type of keratin salt like alpha keratin or the mix of alpha and beta keratin such as pig hair, human nails, or hairs. So that is my presentation.